Hello everyone! Welcome back to Mitzi's Science Adventure Geology Week 2. Woo! Alright, so this week is a little crazy. I've told you before, there is so much to learn when it comes to geology. Earth is a ginormous place and it is pretty stinking old. So, since we don't have as much time as we normally do during the school year, and unfortunately we're not in the classroom setting, we're going to have to kind of jam through certain topics. So, the cool thing about geology is that everything is really connected. So you're really going to be able to understand the big picture at the end. But the little tiny pictures are sometimes hard to fully grasp the concepts, and I totally get that. So, I promise you, if you don't fully understand the concept just yet, ask questions, make sure you reach out to me, but I promise towards the end, everything is going to start connecting to one another. Okay? So, today we're going to really be focusing on igneous rocks and weathering and erosion and that whole process, and we're going to get a little sneak peek into the beginning or part of the rock cycle. Okay? So, before we move forward into the next part of geology, let's do a little recap of last week. We talked about... Why can I not remember what we talked about last week? I couldn't recap without my recap. Ba-dum-bum. Alright, so now that I have my recap on, let's talk about what we did last week. The majority of the concepts that are important from last week are from the Zoom meeting that we had. So if you were not able to come to the meeting, make sure you watch the review of the Zoom video that I posted. It talks about some major concepts that are necessary for you to understand moving forward. Okay, so first concept we talked about was that Earth's outer layer is made up of hard solid rock, and that hard solid rock is actually broken up into tectonic plates which move on top of the mantle. The next video that you get to watch just really goes into all the different Earth layers and gives you some more information on that. We also talked about how sedimentary rocks are formed through compaction and cementation. Those sedimentary rocks form on the surface of Earth. Now, we talked about three sedimentary rocks, limestone, shale, and sandstone, and we talked about how those three rocks are formed as well. Now, we really just talked about weathering and erosion just the teensiest little bit. So, we're going to talk about it a little bit more today, and I have a fun demonstration to really exhibit the fun part of science, if that even makes sense. I'm just trying to use big words at this point. Alright, moving right along, let's go. So, last week we talked about the formation of sedimentary rocks. This week we're going to be talking about how igneous rocks are formed and how metamorphic rocks are formed. Now, the formation of the three different types of rocks is really important to understand because next week we are going to dive into something called the rock cycle. And a cycle means that it's all connected. It's kind of like a circle. And the rock cycle basically shows that all three of these rocks can transform into another rock. Okay, so sedimentary can turn into an igneous can turn into a metamorphic, and vice versa. There's just certain things that need to occur in order for that to happen. One of the things is weathering and erosion. That is why we're going to be talking about it today. But again, next week when we talk about the rock cycle, all of these concepts are really going to be meshed together and make a whole bunch more sense. So make sure you understand what we're talking about today. Make sure you understood what we were talking about last week, because it all connects to the big concept. So let's talk about metamorphic rocks first. I told you last week we're not going to focus too much on metamorphic rocks and that is true, but it is important to understand how metamorphic rocks are formed. Now, metamorphic rocks are always formed below Earth's surface. The reason that happens is because metamorphic rocks need an intense amount of heat, pressure, and time. Okay? Metamorphic rocks are a little different than our other rocks because they actually have to transform or go through metamorphosis from an actual mother rock. A mother rock can be sedimentary, it could be another metamorphic rock, or it could be igneous. And through heat, pressure, and time, that mother rock transforms into a metamorphic rock. Below, all of this is happening below Earth's outer layer. Alright, the hair is up for igneous rocks, we mean business. So, igneous rocks we know come from hardened magma. Now, magma and lava technically are very, very similar. Magma is actually on the inside of Earth, so like below Earth's surface. Once magma hits Earth's surface, when it goes through a volcano and it hits Earth's atmosphere, that is technically lava. So igneous rocks can come from hardened lava or hardened magma. And the cool thing about igneous rocks is they can form below Earth's surface or above Earth's surface. We know sedimentary rocks can only form on top of Earth's surface, so in oceans and on land. We know metamorphic rocks can only form below Earth's surface, so in the mantle. Igneous rocks can form both places. When igneous rocks come from hardened lava, that means that they are on the outside, on Earth's surface, above where we live, where sedimentary rocks are formed. That is considered an extrusive igneous rock. When it's formed below Earth's surface, like in the mantle, that is an intrusive igneous rock. Now, I know what you're thinking. I know. If it all comes from, all igneous rocks come from hardened magma or lava, wouldn't they all be the same? Like, why is it igneous rocks? Wouldn't it just be igneous rock? Because it's all from magma, it's all from lava? To you, I would say, wonderful question. It does all come from that same magma material. However, the amount of heat, the amount of time, and the amount of pressure change the igneous rock type. Specifically because we get the addition or the formation of crystals and minerals. And those are what separate different igneous rocks from one another. Now, igneous rock pretty much makes up the entire outer layer of Earth. I don't want to say it makes up the whole thing because that's not fully true, but the outer layer of Earth is mostly made up of igneous rocks. A lot of the mountains that we see and the volcanoes that we see, those big landforms, are mostly made up of igneous rock as well. So it's all around us, all the time. So, I have a question for you now. If we have igneous rock below Earth's surface, it's being formed, like maybe right below Earth's surface, or actually in the crust but not outside the crust. Basically, it's below Earth's surface. We can't see it. How does it get above Earth's surface? Oh, yes, weathering and erosion. As time passes, weathering and erosion takes off Earth's crust, say, over millions and millions and millions of years. And soon the igneous rock that was once intrusive is now exposed to the Earth's magical being. Magical being? The Earth's atmosphere, alright? Earth's atmosphere. But it's exposed now. And that is called uplifting. You're basically uplifting a rock from the below Earth's surface and putting it onto Earth's surface through weathering and erosion. So today, I'm going to tell you, or I'm going to be able to show you, how igneous rock can turn into a sedimentary rock. And I'm going to be using Jolly Ranchers. Watermelon is my favorite, and anybody who says different is, well, we're just different, I guess. So, a whole Jolly Rancher is going to represent one igneous rock. And I have them all set up into different bags. I have 4 different colors. And the reason why is because there's different types of igneous rock, okay? So we have 4 different types of igneous rocks here in a bag. And we are going to weather them. This is my favorite part. Alright, my friends, so I have my weathering device. Now this hammer, or it's like a meat hitter. I don't know what it's called. My mom's the chef teacher. But this is going to represent weathering. So this is like rain and wind and all of that type of stuff that is going to break these igneous rocks into smaller pieces, which is called sediment. You guessed it. All right, let's get it. Very, very therapeutic, people. All right, that's what we like to see. Remember, weathering is the breakdown of rocks into sediment. So we've done our weathering. We have our igneous rock broken up into sediment, aka smaller pieces of rock. Now we need to do the erosion. Remember, erosion is the movement of sediment. So what I'm going to do is I'm going to pour all the 4 different types of sediment, igneous rock sediment, into this little bag. Once I pour all of the sediment into this bag, weathering and erosion would have occurred on our Jolly Rancher igneous rock. So remember to also, while I'm doing this experiment, to be filling out your chart on your assignment. So what did the igneous rocks look like before I weathered them with my hammer? Okay? And then how did they look after the weathering? That's what you should be filling out in your chart. They could be very simple observations, but nonetheless, you should be able to see that an igneous rock looked one way before it was weathered, and it looked a different way after. Alright, so I have all of my igneous rock sediment in my new bag. Now I want you to take a look at this bag. What do the sediments look like? Are they all the same color? Are they all the same size? So, go ahead. You're right. No, they're not. We have lots of different colors. We have lots of different sizes. Weathering and erosion doesn't just make one specific type of sediment. Any single type of rock can be weathered. And that's what's so cool, is when this sediment forms a sedimentary rock, it's filled with sediments from igneous rocks, from sedimentary rocks, from metamorphic rocks. It is like a melting pot of different types of rocks. So when I moved all my different igneous rocks into this little bag, I was mimicking erosion. Because remember, erosion is the movement of sediment. And now that they're all here, those igneous rocks went through deposition. Okay, so that basically means that erosion moved all of these sediments into one specific place. They are all deposited in this bag. And that happens a lot when rivers carry sediment and put them all on maybe like a sandbank, or they fall to the bottom of the ocean. That is all considered deposition. Next step, let's make a sedimentary rock. So I put all of my little sediments into this plastic cup. And you can see, again, there are no specific sizes or shapes or color when it comes to sediment. It can just all make a sedimentary rock, whatever. Okay? What I'm going to do is I'm going to put this other cup on top, and I'm going to kind of just push it down a little bit, nothing too crazy. And then I'm going to put a weight. This is some Miracle-Gro. And I'm going to put it on top, and I'm going to let it sit there for a while. This is supposed to mimic compaction. Okay, so all this heavier weight onto just these sediments as it gets compacted together. Now you can mimic cementation as well if you put a little bit of water in here. I personally didn't want to, just because it would have made a little bit of a mess. So I actually did this experiment last night. So I have a sedimentary rock already formed, and I kind of, and look at this. All that sediment pushed together with just the additional weight of the Miracle-Gro, and now they're all stuck together. Whee! So now we need to find out, can our sedimentary rock also be weathered? So now I'm going to do a different type of weathering, and I'm just going to shake this sedimentary rock in this little mason jar and see if we get any breakdown of the sediment. Alright, this is my workout for the day. I already see it happening. Look. Wow, already broke down into a whole bunch of sediments. Just with a little bit of movement. And remember, this is symbolizing weather. Okay, so wind, rain, a natural disaster, something like that. Okay? Super cool. So, this experiment was supposed to show you that an igneous rock can be weathered and eroded to form a sedimentary rock. And then that sedimentary rock can then also be weathered and eroded and turned back into sediment. That is just the first part of the rock cycle. We see that igneous rock transformed into a sedimentary rock. Now, the next part is, how does a sedimentary rock turn into an igneous rock? And how does an igneous rock turn into a metamorphic rock? And so on and so forth. And that is going to be a ton of stuff next week. But the next thing we really need to understand is plate tectonics. Okay, so you should watch the next video, which is all about Earth's layers, which was a fun situation. And then our Zoom this week is going to be all about plate tectonics and continental drift. Okay, so I'll see you then, folks. Bye. All that information is super important. There is a hair in my face. Ooh.